I wasn't recording it. Oh well, I'll start recording now so that y'all can reference this later. But yeah, hopefully y'all remember what we did. Okay, let's move on to part three. So part three, again, these are kind of made up. So it says East Carolina. So meanwhile in East Carolina, you only half the votes have been counted and there isn't a clear winner. So again, remember you're an analyst and you're making the kind of statistics and predictions, right? For like a company that's publishing your work. That's what's happening here. But an impatient reader writes to your editor and they say, why is it taking you so long to call East Carolina? This person says, you don't have to wait until the votes are counted. Just wait until the rate of change of the vote share is 0 and then call the state for whichever party's ahead. Since the vote share is no longer changing, the same party is guaranteed to win in the end. And then your editor forwards the email to you, but he also kind of adds this point. I don't think this guy realizes that the vote share could stop changing for a moment, but then can start changing again. In fact, the vote share could have a 0 rate of change at several times during the count, and it could, lean the other way. Can you create an example of a function like this so I could convince them? Okay, so there's somebody who's like, you need to convince them. So of course you need a visual for this. You want a screenshot. And your job is to create this function that's going to demonstrate to this person, like, hey, take a look at this function. It has a bunch of spots where the rate of change is 0, but we can't call a winner yet because as you can see, it's going to go up and down, up and down. So of course, your input P is going to be from 0 to 100 because again, we're talking about percentages. So f of P should be continuous, and it's going to be a plus if you're able to make that connection to our big ideas packet on continuity, like what makes a function continuous and how you could prove your function's continuous. That would be like going up and above. That's just a suggestion. But anyways, should not be a constant. Yeah, should not be like just a straight line, but it should have a 0 derivative for as many values and different values of P between 0 to 100 you could think of. Then you're going to reply to your editor. You're going to include the function you found and demonstrating where it has the 0 rate of change. And again, you want to make your point, and you want to make connections to why your function has a 0 rate of change. What connections can you make to the tangent line, to the slope of the tangent line, to instantaneous rate of change? So that's when you're going to go, to your big ideas packet and make references to those things. So instantaneous rate of change, that's all about derivative. All right, so let's use the chat. What kind of function do I need to make? What does it look like if I want to include lots of points where the instant rate of change is 0? What do I need to make sure my graph has? And I'll just see the chat here, what y'all think. What do I need to make sure it has? Waves. All right, that's a start. So let's first kind of create our function, and then we'll get to talking about big ideas. Yes, waves, and then another more formal way, max and min. Yeah, max and mins, maximums and minimums. So let's take a look at what everyone made. So some groups are struggling. And then another group put our original function. That one's going to be a little bit difficult to analyze or prove. Apollonius's group made this interesting function. And it reminds me of, trig. The only feedback I would give to this group is like these waves down here. When the wave goes below the x-axis, it doesn't make sense because this is saying that when 16% of the votes are counted, negative 32% are going to the Democratic favor. So that doesn't make sense, right? Because the percentages have to go from 0 to 100. So I would maybe shift this function up, play around with it. It's going to be a little bit difficult, but okay, let's see. So that was just feedback for that one. Let's see this one. This one looks nice. They're all in the positive range. This one's saying from 0, it goes to 20. Even though this is like a pi, that's okay. Pi is a number. So this is saying when 10 pi over 3% of the votes are counted, 33% are in the Democratic favor. I mean, this graph makes sense. If 33% are in the Democratic favor, that means that, according to this graph, this right here would tell us that Republicans will win always, I think, because the highest the Republican share gets to is 33%. See, it goes down, goes back up, goes back up. So this one's a good one. If you want to make a graph where the Democrats do win, like overall, oh, I'm sorry, even at 100%, the Democratic Party here would lose too. See if you check it out, only 28.4% of the votes. But I like this graph. We could totally use this one. So this group used a sine function. Let's see if there's any others. And you all are allowed to use anything, even from the stuff we're talking about in office hours, as long as you can explain it and back it up. So if we want to use this, it's fine. I might use this as the example then. Let's see this. This is kind of cool. That's some wild waves right here. Let's just see. So yeah, the only thing that doesn't make sense is this parts, because we can't have negative percentages. But if they shift this function up, let's see, by 1, we'll fix that. Like this, I just shifted it up by 1 unit. Or you could shift it up by 1.5, like so. But then it's going to be very low. Like if you want to make this function taller, I don't know whose function this is, but if you want to make it bigger, what you do is you add a number in front of the sign, like let's say 25. Oh, but then again, it goes below. So then I'd have to kind of add plus 25 or 26, and it goes up. It would just make more sense though. Sorry if I messed up whoever's function this was. I could undo it. It makes sense though. But this would be wild if a vote count was doing that. I'm just trying to see where the maximum is here. I'm gonna go all the way to the tops. There we go. So the maximum for this function would be when 0.67% of the votes are counted, 51% are Democratic. This one, like it looks like Democrat will win because it would end up 51% ultimately as all the maximums, even though it does kind of infinitely keep going down and up. This one's a good function. So whoever did that, I would keep it. You don't have to use my suggestions. I could take that out. I just wanted to, make it make more sense. So I had to shift it up. I'm putting it back to where it was, which was like here. There we go. So I'm going to use, sorry, y'all, I just wanted to definitely show you all that. I'm going to use this one. And you all are free to use this one as well, as long as you're able to explain it. So let's use this one. This one, though, if we want to use it, we're going to have to make the assumption Democrats are losing. So my first thing is I'm going to just take a screenshot. So I'm pretending I'm you, I'm a student. So first off, we need to put in a screenshot of our graph. And I'm just going to go, oops. Oh, okay. This is the only part. Yeah, we're almost there, y'all. It's a short final, actually. It's a short mini final. I like it. Straightforward, to the point. The other mini final wasn't this short, though. I know that. So, oh, right here. I want to just move this. Okay, so this is the one I'm using. And now sending a picture of a graph itself isn't going to help. We now need to kind of make some mathematical convincing. All right, so we've found a function that works. This does have multiple rates of change of 0, but we want to say y. So we're going to tell that editor, we have to explain, reply to your editor, introducing the function we found. So we could say, you're going to explain what function we found. So state your function and state why it has a lot of rates of change that are 0. That's this part. first off, state your function is, I found this function. You're just going to go ahead and type it out. And you're going to describe certain properties of it. And by describing properties of your function, what I mean is give some examples. So for this function, I would say, oops. For this function, example, I have a zero rate of change right here. When 10 pi over 3%, over 3% of the votes are counted, 33% are going towards Democratic, but when I have 10 pi of the votes counted, 7% are going Democratic. So that's why it wouldn't make sense to make the call, right? Because it is going to keep going up and down. So we can't just say one party is going to win over the other. The only problem why this function isn't that great is because in either case, 33% votes going Democratic or 7% votes, either case, the Republican Party in this example is going to win. Just as a heads up, but you could still use this function and even take a screenshot of these two values. So explaining the specific points, explain at least 2 points and what they mean, just like I did right now with y'all. Sorry, there's something in the chat, my bad. Let me check it out. And then there's more to this, so give me a sec. Could you please go back so I could screenshot the graph? I'm so sorry, which graph? Let me know. If you made the number larger, can you change the outcome of who wins? Yeah, you could. Oh, thank goodness. Okay, you got it. Which number, like this one? You could. Let's see. I mean, I don't know whose graph this is. Let's try it. I just know if I make it bigger, like if we want to try to hit it towards 50%, I could, but then I'm going to have to shift the function up so it doesn't go in the negative zone. Let me try 20. And what I'm increasing right here, because this is a sine function, this number in the front is called the altitude, if you all remember from trigonometry. So far when I did that, it's still 40%. We still need like 50 and up for the Democratic Party to have a possible chance at winning. So let me do 30 maybe. 30 is at 50. So then what I got to do is kind of shift this because it goes down -10. I'm going to add 10 to my end right here to make it like this. Now we have it where Democratic votes, when 10 pi over 3% of the votes are counted, Democratic votes 60%. But then of course, when 10 pi of the votes are counted, Democrats have 10%. But then they'll have again 60. So this is an interesting function where it would keep going. So at 100, will they win? Wow, they probably won't. So if we do a little slight shift, they might win at 100%. So this is 49.5, maybe plus 31. Let's see what happens here. So that's if you want to play around with it, you can. I just included the regular. I'm just going to go back to the regular function, but this is if you want one where the Democratic Party wins. Yeah, I think they'll win at this point. Wait, kind of, barely, yeah. Very barely they would win at this example. At 100% of the votes, they'll get 50.5. So they would win because it is above 50, 50.5% of the overall votes. That was fun. So yeah, that's just showing you how we could kind of shift our graph. So y'all are free to take a screenshot of this. If this is the one you want to analyze, go ahead. Let me just pause, give you some time if you want this graph to analyze. Take a screenshot so that you can reproduce it on your own in Desmos as well. All right, cool. So I gave some time, but because I already took my screenshot, I'm just gonna go ahead and talk about the ones, the version where, you know, Republicans will end up losing. Sorry, Democrats will end up losing. So let me go back. So I hope y'all got that screenshot if you're planning to use, it's because I don't know whose function this was. I'm like literally on their Desmos messing with their function. I think it was this one, right? Yeah, it was this. This was the original. Yeah, great. So someone just asked in the chat. So we have to explain why there's a zero rate of change. That's correct. You want to explain why there's a zero rate of change at these locations, maximums and minimums. So does anyone know why? And can you think of any connections to our big ideas? So why is there a zero rate of change, or why is the tangent slope zero at those locations? So let me know if anyone is able to find a big idea that can connect to this. Because the direction is changing. So let's see. So the direction is changing. Are you saying because the direction? So how do we interpret direction? Maybe because they finished counting the votes. Well, at the end, yes. Like, you mean they finish count at 100%. So when 100% is reached, they do finish counting the votes. But at these maximums, they're still counting because they have to hit 100% of the vote counts. But we want to like try to figure out, why does this have zero rates of change everywhere? And let's see, because I want to kind of entertain that idea, because the direction is changing. Can we be more specific? So when direction changes, what does that mean in our graph? And how does that connect with derivatives, tangent line, anything that we've been talking about? Looking back here at our big ideas packet. And then there isn't a tangent line. Well, functions don't have tangent lines to them, but we can create them. So let me like just create some. So why we draw tangent lines on functions is just so we can see how the slopes are changing, or the rate of change is changing. So for example, here's like an imaginary tangent line touching my curve right here. And then the tangent line starts to get less and less as it's approaching this here maximum point. Then it becomes horizontal. Then over time, the tangent line becomes negative, right? Because it's sloping downward, and it continues negative. Oops, let me undo that. Continues negative, but then it's going to, so it's steep, but then it gets less steep as it starts to curve up here, and then eventually gets flat again. And the tangent line goes back up positive. So the tangent line is measuring the rates of change of this. When it's increasing, the function's increasing, the tangent line is positive slope, and it starts to decrease here. And it goes down. So I don't know, that's just me modeling for you what the tangent line is doing as I trace the graph. And the tangent line helps us to see the rate of change, and we can use the tangent line to prove that instant rate of change is zero at maximums or minimums. So what can we say here? Using tangent lines, how can I prove that we do have multiple maximums and minimums that give us an instant rate of zero, instant rate of change of zero? What are the tangent lines doing at these locations? Yes, they're flat. That's correct. So, yep, correct. So there's multiple points where the instant rate of change is zero, and that's because the slope of the tangent line is zero. And I know my little graph is here, but let's see where we could kind of find some so we can know which big idea to reference. Okay, tangent line is a point that touches one point. Slope of the tangent line is the derivative, the instantaneous rate of change. That might be something you want to talk about because we're talking about when is the instant rate of change zero. Well, by definition, the slope of the tangent line is the instant rate of change. So I would use big idea 8 to just explain that. Let's see what else we can use. Big idea 9. So big idea 9 is when we're using the original function and trying to sketch a derivative. So let's see, when your original function has a smooth maximum or minimum, your derivative function has a 0. Yep, I would use that too, because if your derivative function has a 0, that means it's 0 rate of change. So I would use big idea number 9 as well for this part right here. And that's how you would kind of prove that that's where the instant rates of change are 0 at these maximums and minimums. Let's see if you could use anything else. You could probably use this because we're talking about the tangent line is straight or horizontal. That means there's no rate of change. Whenever your original function is horizontal, your derivative function is 0 during that interval. Even though our function is not straight looking at all, it is going to be horizontal, like no rate of change at the maximums and minimums. So that second big idea right here can be applicable. And if you want, you could find more. But I think for this one, big idea 8 and 9 would be the ones we want to use to back up our claim. So 8 and then 9, first and second star for this right here. So again, let me show you this. Oops. Let me show you this. And you're free, like if you're using your own different function, like the one where we kind of manipulated earlier, you're free to even draw on it too to kind of show visually how the tangent line slope is changing over time. You could talk about how when the function's increasing, the slope of the tangent line's positive, becomes 0 at max, and then decreases. You could talk about that. So the behavior of the tangent line. But up to you how deep you go in this one. As long as you like hit talking about why there's a 0 rate of change at those maximums or minimums. It's because tangent line slope 0, and that's how they behave around those points. So I'll just pause here. Let me clear this. So I'm going to add what you should put right here. Then you want to explain how big idea number 8 plus sum of big idea number 9, slope of tangent line, helps you prove that at the maximums and minimums, the instant rate of change or the rate of change is 0. And so you would say that just because it's 0 does not mean we can call a winner of a party, because it's going to keep going up and down. So for that person that was like, oh, let's just wait for the rate of change to be 0, because if we wait for then we could just stop counting and just declare the winner. But you're going to say no, because just because the rate of change is 0, it could go down or it could go up. Or if somebody was looking down here like, hey, look, only 5% of the votes are going Democratic, the instant rate of change is 0, I don't think this is changing, let's call the winner. You're going to say no, because when 50 pi divided by 3% are counted, now the Democrats have 35% of the vote count. So we can't just call a winner when the rate of change is 0. We can't just do that, because we have different types of functions that behave that way, but they go up and down. So we can't just call it just because the instant rate of change is 0. So you want to add that. So add call a winner whenever the instant rate of change is 0. That is, I think, the last part. And then at the bottom, y'all, just in case if you haven't noticed, I am using this rubric here to give you a score. It does become more clear once I give you a grade and I start to highlight this at where you're at. But yeah, once you do your submission, let me know. You might need some time to continue working on this though. But yeah, awesome, y'all. So it is, oh my gosh, we have about 10 minutes to our break, y'all. I think we got most of this done. Let me know if anyone has any questions or anything, but if some of you are ready to go ahead and log off and just work on this mini final, using what we discussed, you're free to do that. I don't have more office hours for AP Calc today, but we do have office hours by appointment tomorrow, Friday. So just let me know if you want to continue to meet on this, and I'm happy to. I'm also going to grade some more tomorrow if you get yours in today. All right, y'all are free to get going unless you have a question. Yeah, this was great. I did record only like the second half of this, so I'll send what I recorded. I accidentally was not recording at the beginning, but I'll send what I can. Yes.
I do have a question
Yeah.
for the, because you have in the Google Classroom, you have the mini final two, and then the answers in a reflection form.
That's correct.
Oh,
Yes. Did you check out the video that was attached there?
to which
To the
to
one,
the
yeah, the one that says answers and reflections.
oh no, I didn't see it.
It kind of explains it. So the
Okay.
thing we have to do for next week. So basically, if you don't get to do it next week, I mean this week, like if you don't get to do that portion, you're just gonna have to do it in testing day. But it does save you time if you already do it ahead of that. So that's why I made that assignment for everybody, because everyone's going to end up doing it whether you got advanced or not. It's a reflection form, and you're just going to copy and paste your answers of your mini final into it. Yeah. So just check out the video, it'll make more sense. Yeah.
Okay. And then also you said if we could explain the limit. Was that for if we you said if we could explain you said something about explaining the limits?
Yeah. Are you talking about for what I said for advanced?
Yeah, yes.
So if you go to the limit, so first off, I mean, everyone should say that you're going to come in from the left and the right. That's like, you have to do that if you want the limit to exist. But if you're able to kind of determine what that limit was, and we did when I rounded it, I'm like, okay, it's this number. And you're able to put it in limit notation, like the limit as x approaches, and in that scenario it was 100% or 100, right? The limit as x approaches 100 because that's the point where it became undefined. um
And we're just finding the limit. We're not like figuring out. We're not because we're not trying to figure out if it's continuous or not. We're just finding the limit of it, right?
that's correct. Yeah, we're not trying to prove whether or not it's continuous, but you can, you don't have to, but you can say, for example, I know it's not continuous because, and take a look right here, that the portion that has a hole is called a removable discontinuity. You could just make a reference like that. It will make your explanation stronger. Because that hole that was at the 100 is called a removable discontinuity, but you don't have to do all the steps and prove it.
Okay. Thank you.
You're welcome. Cool. Let me know if anyone else has any questions before I end this meeting, or any other extra supports y'all would need, or if you'd like to meet extra. Can we get a private room real quick? Like me and you kind of thing. I could do that, or I'll wait for everyone to log out too, or we could make a breakout room. Yeah. Okay. All right, y'all. So if you're cool, don't have any more questions, I hope you all have a great like lunch break. So you're gonna go back to your advisory at 1. So just make sure you go back into your advisory at 1 so they could check in. And please shoot me a text, email once you're done and you want me to check your score. All right. Cool. I'll check out the submissions either later today, or we'll see tomorrow morning. So I could give you all feedback. I have a bunch of like pre-calc as well, but I'll try my best to get to everybody's. All right. You're welcome, y'all. Thank you so much. Enjoy your lunch. I'll send what I can, whatever part I started recording on. Yeah. Bye, y'all. Bye, everybody. Mm. All right. So cool.
So I have a question, Mr. Dono.
Yeah, go ahead.
So I put the equation on here,
Mhm.
but it's showing me like a weird graph.
Oh, can you do you want to share your screen?
Yeah, let me see. So it's showing me this. Like
Wow,
when you zoom,
that has a lot of dips.
and this is the equation I put in,
Okay.
but it's showing me all this.
Okay, so wait. Let me try to let me try to get the same
When I
thing.
zoom in,
All right, the two things I want, because there's like a lot of maximum minimums and it's spiraling really quickly. What is
uh, 13 cent,
13?
uh, 0.15 m plus 20.
Si quieres decirlo, pero no sé si
Just tell you that
no se va a enojar. No.
F of m. Yep.
let's see what I see. Well, I see this.
Let me check. Let me rewrite it. Here, let me delete it again. M. Thirteen cent and zero.
So, just like I'm saying here today, what I want you focusing on is the words in money. Cherry, we have been practicing with pictures and with the numbers. But today I want to teach you that.
Yeah, it's still showing me that.
Really? Okay. I wonder if you're like this is like
Here, let me just reload my.
that's odd. Yeah. Is it the same whole function right here? Is it 0.015?
And then it says you're dying. Now maybe you forgot.
Hmm,
Okay, we're practicing.
that's what's showing up on my screen.
So it's not 0.15, it's this,
Yeah, but I keep putting 0.15 though.
and it's still doing that.
Yep.
That's weird.
Here, I reloaded my thing, so let me just try it again.
You know how you could do this? Can you share me your graph? You know
No,
how
Maria, look at me. Look at me. I'm done. How much?
Hold up, I think I got it now.
See, the answer's right here if you forgot. It's okay.
Okay, I got it.
Use the chart.
does it look like this now?
On every.
Yeah, it looks like yours.
That was weird. I have no idea why.
And I also like really don't understand what number 3 is asking. Like, I got what you were telling us, but I was still kind of confused of when part 3 was asking us to do.
Okay, specifically, okay, tell me what is confusing, like, first off. So we got
Like, how, let me just read the question. Sorry, it's loading.
like this with the like editor stuff.
Well, I understand what we gotta explain, but what does the equation f of p got to do with it?
Oh, well, f of p, like basically right here, right? If you're seeing my screen,
Uh huh. Uh huh.
this is represent percent.
You sound muffled. I can't hear you.
You can't hear me?
No.
Uh, right,
It just sounds kind of far away.
okay, let's see. Are you able to hear me now?
No, I don't hear you yet.
Let me type it.
Okay.
So I'm gonna say same as what do we have? It was
Oh, I hear you now.
okay. So you know how right now is f of m?
Mm-hmm.
F of p is the same thing as f of m. So f of
Uh-huh.
p is
Yeah, I understand that part,
uh-huh.
but what does the 0 and the 100 have to do with it?
Oh, because P is a percentage, and P has to go from 0 to 100. So that's why when I was showing you all graphs, and I was like, this one doesn't make sense because it's negative, like this one.
Uh-huh.
So I would say like this one would not be a good example of a wave to use. Like, yes, it has multiple maximums and minimums.
Uh-huh.
It's not between 0 and 100. It's not possible to have a negative one
So it has to be a positive 0 to 100 percentage.
because percentages also from 0 to 100, right?
Uh-huh.
That's why I said, okay, I'm gonna use this function, and then I use this one because it was above
Uh-huh.
100, and
Uh-huh.
the vote counts didn't go above 100.
Okay, I can do that.
So then the max point, what would that represent?
The maximum.
Uh-huh.
So,
I know how to do it, Miss Wash. So I'm doing it.
Yeah.
so this represents. So first off, I need to find out what 10 pi times 3 means. Like go number.
You have this little.
10 times pi. I don't see pi. Oh yeah, 10 times pi, and then divided by 3.
So a lot of learning.
So on my phone, right, I figured out what this number was.
All right.
Uh-huh.
Right over here, you see an X under red.
Uh-huh.
0.5. So that's if you like, that's messy, but okay, that's 10.5. So what that's telling me is when 10.5% of the votes are counted, 61% are in the Democratic favor. So that's what that point is telling me. I wonder if you're there. And then, hey, Danny, I see your thing. The pre-calc off.
Okay, so I'm doing it right
Let me type it.
What?
Sorry. Hey, James. I was just
Yeah.
okay. So this point, I had to just use my phone to do 10 times pi divided by 3, so I could just figure out what that is. So that's about 10.5. So what this
Mhm.
is when 10.5% of the votes, total votes are counted, 61% are in favor of Democratic, or 61% of the votes
Mhm.
are Democratic. So that's what this means when you're asking about what does this mean?
And then the minimum would be when 0% of the votes are counted, right?
Well, here actually it's saying,
When 10 pi of the percentage votes were counted.
yeah, how much are towards Democratic?
And so they're trying to make us figure out about 50%, right? I think that's what it was asking.
For this one, no. So this one, like, there was a guy who was saying, like, oh, y'all should stop counting whenever there's like a maximum or minimum, or he's saying you all need to stop counting.
Mm.
The instant rate of change is 0. But we want to prove to him, like, no, you can't do that because, for example, down here, when 10 pi% of the votes are counted, 1% are going Democratic, right? So somebody could already stop the count and be like, okay, Republicans, you win because look, only 1% of the votes are Democratic. But if you wait long enough and continue to count, right, when you've counted 50 pi divided by 3% of the votes, it goes back in favor of Democrats. So we can't just stop counting when the instant rate of change is 0. And that's what that person that was writing, the editor, was trying to say, like saying, stop the count because once there's no rate of change, we can declare a winner, but that's not true. Because just because there's no rate of change does not mean the vote count can swing one way or another. If that makes sense.
So then for the next point where it says 50 pi over 3, that's a different percentage, right?
Yeah, it is. So it should be increasing. So let me see on my phone. So in order to figure out that number, I'm going to do 50 times pi equals, and then I have to do divided by 3. That is 52%. So when 52% of the votes are counted, the Democrats
So
are at majority.
Mhm. So for when we multiply it, Do we have to use pi or can we just use 3.14?
You can use 3.14. Yeah. And here, 10 pi was, let's see, 10 times 3.14. I got 31.4 for this one.
Oh, okay, I see. So then once we get close to 100%, then it would be best to now answer the question about the graph we used and demonstrate how each time, like let's say each 10% or between the numbers, between the max and minimum points,
Mhm.
the percentages of the Democrats or Republican votes changes throughout increasing amounts.
Yeah,
I don't
that's
know if you understand.
yeah. So for this particular graph, it's at the maximum and minimum points, it's either going to be 1% going Democratic or 61% going towards Democratic. So it makes such a huge difference on who's going to win. Because if only 1% is going Democratic, but then if you keep counting, then 61% goes Democratic. So we can't just, stop the count. So my thing would be to that guy who said that is like, no, we need to actually wait till we count 100% to get our winner,
Mhm.
right?
Mhm.
We can't just wait for us to stop counting whenever we have a zero rate of change because, like
Mhm.
I said, every after counting, I think it was every 10%, right? Or you said 10%? Because from 10 to 31%.
I'm gonna go now, Mr. Dono. Be
Oh,
safe.
sorry, I didn't see the chat, but yeah, we have it at 1:15 today, pre-calc. Okay. So you could say between, I mean, like, because from here, 31% to 52%, that's like 20, between every 20%, I would say, you get like 1% goes to 61%, every 20% of the vote count, I guess, because you were kind of saying every so often. Up to you though, if you want to talk about it like that, James.
Okay. Um. So I have one more question.
Yeah, go ahead.
So on your graph, you have 30 and 31. So we can change those numbers, or
So that's based on this graph. Do you have this one, this exact one?
yeah.
Yeah, so that's because I just converted the ones that have pi into a percentage that I understand by multiplying out the pi.
Okay.
So this one, 10 pi was about 31% of the votes. 10 pi divided by 3 is about 10.5% of the votes counted. This one was about 52% of the votes counted. And then you could like figure out what these are too if you'd like. But ultimately, we would know the winner once we hit 100% of the votes counted, which would be right here. And this one would be like a slimly, the Democrats would win at like 50.5% of the votes go towards Democrat.
Okay. So it would be best to screenshot this. I mean, screenshot the graph and determine the point on 100, right?
Yeah, but you wanna make sure you explain to the guy why we can't just stop counting at these maximums and minimums. And you want to make sure that you explain why is the rate of change 0 at these maximums and minimums, just like we were talking about earlier. So remember how the tangent line became horizontal at these points, the maximums and minimums? You want to just make that connection to the big ideas, and then you'll be set for that one. You could also go ahead and type it out, and I'll give you feedback too if you want me to check it.
Okay. I will probably have it done before our next office hour. Um, but I can just text you and remind if I have any questions, right?
Yep, you can always do that, and I'm happy to. You can also share me on it if you want me to give feedback too. I'm happy to do that.
Okay. Thank you, Mr. Dano.
All right, you enjoy your break right now.
Okay. Thank you. Bye.
Welcome.
Ahorita vengo, Jen. Yo cuando vengo vamos a